Hey there. So today we are going to solve another LeetCode problem, hard level, named permutation sequence. And it goes like this. The set 1, 2, 3, and so on n contains a total of n factorial unique permutations. By listing and labeling all of the permutations in the order, we get the following sequence for n equal 3. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Given an n and k, return the kth permutation sequence. And there are some examples here. Example 1 and 3 are about this sequence exactly. So the third element in the sequence is 2, 1, 3. The first element is 1, 2, 3. And there is some example about n equal 4 and element number 9. So, before starting working on that, let's first agree that we are going to work with the integers to return this string. So our sequence is going to be some kind of array of integers, and then to return the expected string, we are going to map the elements of this array to strings and then join together all the strings. Let's focus a little bit on the way this sequence of permutation is made. So currently we are working with numbers, but to be honest, we can work with letters, emojis, with objects of any kind. So to create this sequence, we are going to iterate through all of the elements inside this array, and we are going to try to put each element as first element in the permutation. And then this element should be followed by all the sub-permutations of the subarray. In this case, the subarray is the original array with the first element excluded. What is also interesting is that if you take a closer look on the subsequence of the subpermutations, you would see that it follows the same rule. We are picking each element as first element of this subpermutation, and then follow the rest with the sub-permutations of the sub arrays. I hope this explanation was clean enough. And now let's check a little bit on these packs or sets of permutations inside the general sequence. So how many permutations are there prefixed with the first element? Well, it could be some number, but it would be the same number as the amount of permutations prefixed with the second element and with the third element, and so on and so forth. And basically, these sets, they are equal in size, which means that if we have an index of our permutation in the sequence, then we could divide this index by the amount of these packs, which is n, the amount of elements, and find out in which pack or in which set should we seek for our permutation. For example, if the size of the pack is 10 and we have element number 25, then we would divide 25 by 10 and find out that it's the third 10th in the sequence. It means that we are able to use some kind of recursion to find an index of the pack inside the general sequence, then inside the subsequence, then inside the sub-subsequence, and so on. At each step, we would be also able to find the element which is used as prefix for that permutation or sub-permutation, and so we would be able to restore the whole permutation which we are looking for. Let's start by creating a method getPermutation, which is using the array of numbers as a first argument and index of the permutation as the second argument. And it's going to return the array of integers, the permutation which we are looking for. If we would check the index of the permutation, then if it is 0, then it means one of two cases. Either our recursion went to its end and numbers contains only one element, or we are just looking for the first permutation in the sequence. And in any way, it is equal to the array itself, and we can return it straight forward. Now, what is the size of the pack at each iteration? If you take a look, the task says that the set of 1, 2, 3, and so on n contains a total of n factorial elements, which is 1 multiplied by 2 multiplied by 3 and so on and so forth, multiplied by n minus 1 multiplied by n, which is basically the same as n minus 1 factorial multiplied by n. And if we would divide these by the amount of our packs by n, then the size of pack is going to be equal to n minus 1 factorial. Okay, it means that we do need some kind of method to calculate the factorial at each step for all kinds of values. Let's create it. It's going to use one single value as an input argument, and it's going to return the integer value as a result. I would also prefer to use recursion here, because as you can see, the factorial of n is the same as the factorial of n minus 1 multiplied by n, right? So we can use it. If value is equal to 1, then the result is going to be 1, right? Alternatively, the result is going to be equal to value multiplied by factorial of value minus 1. Okay, it works, but also remember that we are going to call this method at each iteration, and we are going to recalculate those factorials a lot. So let's create cache to speed this up. So it's going to be a dictionary of integers for integer keys, and as a first line in the factorial method we are going to check for our result in the cache for this particular value. If it is there, we are going to return the result. If it is not, then well, we are going to reuse our code here, but also we would put the result to the cache just before returning it. Alright, so now we are able to finally calculate the size of pack or set of our permutations using the factorial. which is going to be the factorial of numbers count -1. Finally, we are able to divide our index by the size of pack and get two numbers. Right. So we are going to have the quotient and the remainder. The quotient is the index of pack, and the remainder is the sub-index inside that pack. Right. Now, finally, we are able to get our prefix number from our numbers, which is going to have the same index as the index of the pack. Right. Finally, we need to start the next step of our recursion, and for that we would need to create the new numbers. So it's going to be equal to the numbers, but as we agreed, we would need to remove the original prefix number from that. So the rest of the permutation are the numbers. We are going to get them using the same method. So, and as for index, as we agreed, we are going to have to use this sub index. Finally, the return result would look like prefix number joined together with other numbers. All right, so finally we are able to use it, to use this code. The only thing which I'm thinking about right now is that we are creating the new numbers at each step of the iteration, which is not good, right? Let's instead use the input argument and remove the prefix number from the numbers directly, and then reuse the same array. What is left now is that we need to create the original array to start the iterations, which is going to be an array of values from 1 to n. So the result is going to be calculated from array, and as for index, we are going to use k minus 1. Let's check for compilation issues. I think there are some. Yes. Over here. Anything else? Numbers, of course. And finally, over here. Yep, the initial test cases are passed. So let's submit the solution and check the results. Nice. So as you see, the execution time of this solution stays at the edge of threshold, that's why it shows 0 milliseconds and beats 100% of other submissions. So I hope you enjoyed this. If you'd like to see me cracking on other LeetCode problems, then please put your request to the comment sections, and see you later. Cheers!